like to start our session. So we are starting like as the webinar named as blockchain technology. This is the most disruptive technologies of our time. Before we start into this blockchain technology, uh, let me first tell you that whenever we hear the word blockchain, we will be just getting an idea like of a Bitcoin or crypto.
Excuse me, ma'am. Durga ma'am, can you click on hide?
Yes, ma'am.
Besides, yes, ma'am. It's perfect.
Yes, thank you. When we hear the word blockchain, we will be just remembering like a word called as a Bitcoin or cryptocurrencies, because most of the time we'll be hearing the word Bitcoins nowadays. As we are hearing about blockchain, first of all, we'll be hearing the word Bitcoin only. But Bitcoin is only just a feature of blockchain. Not only in Bitcoins, blockchain can be implemented in various areas like finance and many other areas. So let's explore all those. And before starting of this blockchain technology, we need to have the fundamentals of any of the programming languages and some cryptographic basics. And I'll be explaining this in this webinar. And we need some idea about databases and some financial knowledge. So first of all, what is a blockchain is nothing but a blockchain is termed as a chain of blocks. Here, block is termed as something like a set of transactions. The transactions here you may not term as like any financial transaction. Maybe any work which you like to store. Uh, Either it may be related to your academics or student attendance or anything that will be considered as one block. So we are naming that as a transaction, and block is nothing but it is a collection of transactions, and that collection of transactions are being linked with each and every one by using a chain, and that chain is called as a cryptography. And here, as I mentioned you earlier, we are going to store our transactions in a form of a block. And a block consists of our original data. Original data, as you all are aware that some set of information is called as a data. So our block consists of three things. One is the data, and the other one is the hash value. For every transaction we do, we give the hash value, and even the block contains the hash of our previous block. The real-time example to make you clear about this blockchain is we are taking the most popular issue in our country is regarding voting systems. So our voting systems, till now we are following our traditional voting systems by using our manual elections. So whenever a person will vote, the election commissioner or the election related people, they'll collect all the elections, all the votes, and they will calculate that, and they will produce the results after a long time. But blockchain gives us solutions for that. Digitally they can vote by using their Aadhaar card, because Aadhaar number is unique for each and every person. By using our Aadhaar card, they can give the vote, and the blockchain, what it does is it will calculate automatically all the votes. As soon as the time has been completed, it will calculate all the votes, and it will give the results for us within a few time. And one more live example we can take is that in many times we are seeing whenever we visit some restaurant or something, many people tell that food is not good, or the person is he has got food poison, he has been affected by food poison. So in the day, using blockchain, we can find out, trace the origin, whether onions or lettuce or what items have been used preparing that food, and food, that food, using that made find out so that the food and all blockchain, so what happens is only we can write. We don't have to delete it or to erase it. And the next building block blockchain is.
Excuse me, Durga ma'am. Durga ma'am.
Yes,
your voice is cracking, ma'am. You can turn off your video, ma'am.
Okay, ma'am.
Your voice is not clear. It was cracking. So I think there is some network issue from your side. So you can turn off your video.
Yes, ma'am. Ma'am, is it okay now?
Yes, ma'am.
Hello.
Yeah, yes. Please start. Please start. I am checking.
If the PPT is okay, ma'am.
Yes, PPT is okay.
Okay.
PPT is visible.
So the next one is, yes, ma'am. Okay. So the next block is cryptography. Cryptography is the most important thing of this blockchain. So cryptography is nothing but we have here two types of text. One is plain text and the other one is the cipher text. So here our original data will be converted in the form of cipher text. So cryptography plays a major role here. And the next one is trust systems. So trust systems is also called as consensus. We have an algorithm also that will be discussed later, as this is only just the introduction. The trust systems are nothing but, as I have taken an example of voting systems. So with the same example, I'll be explaining you. The trust systems are nothing but, in traditional election systems, we need election officers to validate the votes. But when we use the blockchain, the network itself verifies the votes and it will check whether the vote is valid or not, and it will eliminate all the middlemen like these election officers and all. We need not take their help for counting the number of votes and giving the result. So the trust systems help us in place of this manual things. The network itself verifies whether the voters are genuine or not, and it will produce us. And the next block is business rules or smart contracts. So these are nothing but they are the self-executing rules. So self-executing rules are nothing but they will they will count the votes automatically once the deadline is reached. For example, if the elections are being conducted till 5 o'clock, as soon as the time is being completed, the blockchain itself, it will count the votes automatically. And here everyone has an assumption that the blockchain and database are same, because in blockchain also we are storing the data, and even in databases also we are storing the data. But blockchain and databases are completely different. In database we can do operations like create, read, update and delete. And the database will have one administrator, and administrator will take care of all the things in that. Whereas and one more, we have relational database also in that. Whereas blockchain, we can do only two things, that is we can read the data and we can append the data only. We cannot delete the data or we cannot alter the data by using the blockchain. And in this blockchain, we cannot, like I already told you, that we can only store the data. We can, once we write, we cannot delete the data from our blockchain. And the most important thing is this blockchain technology is being designed for decentralized applications. That means each and every data will be shared to all the nodes in that particular network. And uh, blockchain follows distributed ledger technology. As I told, we have centralized systems previously. So centralized systems, what they used to do is they used to follow client and server architecture, where one or more client nodes will be directly connected to the central server. Here, what happens in centralized system is if there is a crash in one node, the entire like the central node, if we have a crash, the entire node will be spoiled. The example is our ATM system. If our bank server fails, we will not be able to do any sort of transactions from our ATM. We cannot withdraw the money, or we cannot do. Even we can take our social media like our Facebook or Instagram. If those servers go down, many millions or billions of users in the worldwide, they will be getting disconnected. So previously we used to use that centralized system, and now we are using this decentralized system in the blockchain technology. So decentralized system is nothing but there is no single authority for this. Multiple nodes, here in the diagram you can see that multiple nodes will share the control, and there are only fewer bottlenecks. So fewer bottlenecks in the sense, you can see our water bottle. The water bottle will be flat at the bottom and narrow at the top. So most of the water will be filled at the bottom side. That means whatever the problems will have, that will be less down here. So in decentralized system, what happens is everyone, like every node can share the control, and it will be highly available to its network. No single authority can control the everything. And we have some advantages of a decentralized system. So the advantages are it is highly available to each and everyone. And as I told you, the performance of bottlenecks is nothing but the most of the problems will be overcome. Like instead of that peak stage, it will be overcome. And here we follow the distributed systems. Distributed systems are nothing but in the diagram you can see there are several number of nodes. So these nodes are called as peers. And this distributed system has low latency, and here each and every peer will have the communication. So we have peer-to-peer communication here, and all the nodes, instead of keeping burden on a single node, here all the nodes will work together towards the goal. So decentralized, this distribution systems will take decentralization more further. And we have advantages of distributed system, as we have peer-to-peer connection, and we have, compared to centralized system, in distributed system we have low latency. And in blockchain, it follows distributed ledger technology. Ledger is nothing but, as we write in a notebook, it is same as a notebook, but this ledger is different. Like once we insert data into the blockchain ledger, it cannot be deleted. It will be stored. Just you can add the data into that. It will be safe, and you can't delete that. So this distributed ledger, what it does is, it is a replicated plus shared database across the regions. So here it needs peer-to-peer network. And this blockchain follows this distributed ledger technology. For example, here you can see two types of diagrams. One is centralized ledger and the other one is the distributed ledger. In centralized ledger, we have a server, like a central server, and all are being connected to that. Whereas in distributed ledger, we have different types of nodes, and each and every node is interconnected with each other. So you can take an example of a classroom. Instead of each and every student giving attendance, what we do, if one teacher keeping attendance, and every student write it down in their notebook. If one student tries to cheat by writing their name in that, it will not affect that. So that is a distributed ledger. Now, so that is the overview of blockchain. So now finally, what is blockchain? The real meaning of blockchain, it is a decentralized ledger. So each and every node will have access to all the data. If once our data will be stored in multiple systems, also our the other system. So blockchain is nothing but it is a decentralized ledger, and it will record information permanently and in chronological order. It uses cryptography and it uses peer-to-peer networks. So here it is like a what we call, it is like a notice board. Anyone can pin the notice. So because everyone, for example, in apartments or anything, if we pin the notice in the notice board, everyone can view that. Like we cannot remove that. Even if we try to remove also, the history will be preserved in that notice board. So blockchain is nothing but a distributed ledger. So this is the blockchain ecosystem and the structure. Here what happens is, if we want to do any sort of transaction, we have to request first, someone will request for the transaction, and the requested transaction will be broadcasted to a peer-to-peer network. It may be consists of different types of nodes, and then when the transaction is being requested, the network will validate whether the transaction is being authorized one or not. So once it will check whether the transaction is authorized and verified using the cryptocurrencies, contracts, or any other information. And then once verified, the transaction is combined with other transactions to create a new block, because we are requesting to do some transaction. Whenever we request for a transaction, we are to create a new block, so that when our transaction is verified, we will get access that we can introduce or we can create a new block. So here in this blocks, there is a one block in red color. This is the new block which we are be adding to this existing blocks. So when our block is, this is our block as the user requested for his transaction, this block is being created. So this block will be added to the remaining blocks in the blockchain. This is called as the blockchain. When a user is requesting for anything, so that transaction will be verified by using all these things. The transaction will be verified and it will create a block. So then the transaction is being completed. This is our blockchain ecosystem and the structure, how it will work. So here, as I explained in the diagram, it will record all the transaction information in a chronological order, and it uses one-way hash cryptography. So it uses a hash value for each and every transaction, and it is visible to all the permissioned users. So we have here two types of users. One is permissioned users and permissionless users. So these transactions will be visible to only the permissioned users, and it uses peer-to-peer transmission, and you can trigger any transactions automatically. And we need not require any third-party assistance. Directly, whatever the transactions we do, that will be stored in the blockchain in the form of blocks. So we have different features of blockchain. The main thing is it is immutable. The data is immutable. Immutable is nothing but If you want to modify a piece of information, if you want to modify any information, you should modify in all the nodes of the network, because as I told you that each and every node is interconnected to each and every node. So if you want to modify in one node, the interlinked node of that also should be modified. So it is impossible to modify the entire network. And this is decentralized. All the information is shared among the nodes. Information is not stored in only a single place. So this prevents hacking. So if it is placed in only a single system, it might be easy for the hackers to hack the system. As this is decentralized, all the information is shared among the nodes, and it has some enhanced security. Security is being given using public and private keys. So if the user knows either any one of the key, also they can modify, because that is being encrypted by using the public and private key. You cannot read or modify it without the proper keys. And it follows a distributed ledger. That is, every node will have a full copy of the blockchain. If one node is hacked also, others will have the original copy of that. So you have different advantages of blockchain technology. The first one is it has a good traceability. That is, every participant with permission can verify the transactions on the ledger. There is one shared source of truth, so that each and everything becomes simple and there will be no sort of disputes. And it has enhanced security. That means all the transactions are being encrypted and linked to the previous one. So if you want to alter one transaction, it will break the chain and it will be immediately noticed, or it will be immediately brought to the notice. And the next one, it has the improved traceability. So traceability is nothing but this blockchain creates an audit trail. Audit is nothing but you can follow an asset like from origin to destination. For example, if you consider our food, like as I gave the example in the starting, like if we visit some restaurant, so there will be some batch of items we will be taking to prepare some food. So when a batch is contaminated, so retailers will trace the exact farm from where we got that item. Within seconds it can be traced, and we can recall only the affected items rather than this entire food items. Whatever the affected items are there, we can remove them and we can use only the items which are good. That is called as an improved traceability. And the next advantage is increased efficiency and speed. So record keeping is done here in digital ledger. So you can make the repeated data here. And one more is the reduced cost here. So if the network and the code can use the rules, you don't need any intermediate people to give guarantee that our data will be secure here if we go for this. And the structure of blockchain is, the blockchain structure consists of block size, block header, transaction counter, and transactions. So block size is nothing but the overall size of the block. This block size consists of header and transactions. You can assume, as I told, the ledger you can consider as a notebook. So in that way, this block size will not exit it may not be like more than one page as if in our notebook. And next one is it consists of block header. Block header is nothing but it contain all the metadata, that is the summary. The summary of all the blocks will be stored in the block header. And the next one is transaction counter. How many transactions are inside our block will be retained by using this transaction counter. And the next one are transactions. So transactions are nothing but our actual records. So what all the data we keep here, either our payments or your OT systems, anything, all transactions will be
Durga
stored in
ma'am?
this transaction. Yes, ma'am.
Excuse me, Durga ma'am. Yes, ma'am,
Yes, ma'am.
your voice is cracking again.
Okay, ma'am.
So please check your network.
1 minute. Yes, ma'am. Now is it okay, ma'am?
Yes, now it is okay.
Yes, ma'am. Thank you, ma'am. And the next one is a Genesis block. So as in our notebook, we have the starting page of our book. The starting block of our blockchain is called as a Genesis block. So our chain starts with this block. And if you traverse backward from any block, you end at this Genesis block. For example, like in hospital, if you want to make a record, the Genesis block, it might encode the member hospitals and roles. And if you want to join any new hospital later, everyone can still body back to that first that track of records, like where they have visited and all. So Genesis block is nothing but to be like the first page, as we have a first page in our notebook. So in blockchain, the first block of our chain is called as this Genesis block. So I have shown you the structure of a block. In that we have the block header. So block header is nothing but the block header will store all the metadata needed, all the metadata which is needed to link the blocks, like a previous block hash. So previous block hash is nothing but this is the fingerprint, like the hash value of our previous block is called as the previous block hash. And next one we have as metal root. This metal root in that is the summary of all the transactions. The next one is difficult nonce. This difficulty and nonce, they are being used by POW is nothing but proof of work for the hash puzzle. So blocks are being linked referencing the previous block hash in a legal list, but practically executed. So full key and complete the linking. So what here you can see is we have a hash value for each and every block, and a block contains different types of items. So each block will be given some hash value, and those items will be linked, like each hash value is being linked. It is like our linked list as we do in our data structure. So this is like a linked list. Here each and every block has been linked by referencing the hash value of our previous block. And the most important thing is cryptography in blockchain. So cryptographic hashing. So we have some hashing techniques which we follow here. So hash is the main use of hash function is to secure the blocks. But how we can secure is where we use the public key cryptography. So each blockchain user consists of two types of keys. One is the public key and the private key. So public key is like the email address which is shared to everyone, whereas private key is like our email password which is kept secret with that particular authorized user only. And what this cryptographic hashing does is you need to sign in into your network with your private key. So the network verifies it by using your public key, because we give our data by using our email ID. And once that email ID is called as our public key, and you need to sign in by using the private key, that is our password. And If the signature matches, the system will recognize that he is the authorized person, and it will give the authentication for that particular user. The real time example is our Gmail and even our UPI transactions also. If we give our UPI pin incorrect, as because the UPI pin is our private key, and if we give a UPI pin incorrect, we might be getting alerts like the pin is being mismatched in that way. So cryptography is nothing but it will convert our plain text to ciphertext. We have different types of algorithms for that. By using those algorithms, cryptography can be. So here we have that like initiation and broadcasting of transactions. So that can be done by using, one is by using the digital signature, other one is by using public and private keys. Next, it will be validated. Our transaction will be validated by using proof of work, like whether we have given the correct password for our Gmail or not. And the next one is by using the chaining functions, that is nothing but the hash function, because each and every transaction here will have a hash function. And next one, how we do cryptography in blockchain. We have in the previous slides, we have seen their Merkle root. So for following that, we have a Merkle tree. Here in this diagram attached, you can see here a tree with a Merkle root at the top. So this Merkle root is nothing but, here what happens is all the transactions are being in a form of a block. The child nodes, you can see here down A, B, C and D. Here all the transactions will be taken in the form of a blocks. And we will be hashing each and every block. Hash A, hash B, hash C we have here. So these, each and every one, these will be becoming as the leaf nodes. We will be hashing each and every transaction in the block. Now, in the third step, we will be hashing each and every hash function. We will be pairing them. These pairs are called as parent nodes, hash A and B. So it will be as hash AB. And here hash C and D, we have like hash CD. This hash AB and hash CD are called as parent nodes because we are pairing these hashes in order to form this parent node. And this process will be repeated until a single hash value remains. So that single hash value is called as the Merkle root. So here we have the Merkle root H, A, B, C, D. So how it works is, first thing, we take all the transactions in a block. Here we had 4 transactions A, B, C, D. All the transactions are taken here. Down you can see. And we are hashing each and every one. So these are called as the leaf node. And we are going to pair all those hash pairs. And we call these are parent nodes. And this process will be repeated until a single block or a single hash remains, that is as the Merkle root. And technologies, we have 3 types of blockchain technologies. One is permissionless, it is also called as a public blockchain. The other one is permissioned blockchain, it is also called as a private blockchain. And the other one is consortium blockchain. So these public blockchain is nothing but anyone can read the data, anyone can join, and anyone can write the data into that. The example, like it is a decentralized one. There is no transparency. It is transparent and it is open to everyone. And the private blockchain is, it is permissioned. It will be controlled by a single authorization. Single organization only can manage this private blockchains. Only authorized users can participate, and it is more efficient, but it is less decentralized. And the last one is our consortium blockchain. So this consortium blockchain is been controlled by group of organizations. And here we have the like the comparison between the public blockchain and the private blockchain. Public is open to everyone. whereas this private is we have a certain type of permissions. And public, when compared, first I will be telling about the public. The public blockchain is slower, and its security will be given by using the consensus algorithm, and any anonymous user can use this public blockchain, and the data will be publicly available, whoever will connect to that. And there will be some transactions fees required, and the examples are the Bitcoin and Ethereum. Whereas this private blockchain, it is the permissioned blockchain, and the speed of this is faster, and we have some set of, this is the main thing, we have some pre-approved participant, because access will not be given to everyone. We have pre-approved participants if we know the identity of our user. Here we have some differences or characteristics of these are the features, like these are the characteristics of blockchain, like Bitcoin, Ethereum, and Hyperledger. So we have different types of permission restrictions. So Bitcoin permissionless and Ethereum is permissionless, whereas Hyperledger is permission. And next characteristics is restricted public access to data. The Bitcoin is public, Ethereum is public or private, and Hyperledger is private. Whereas Bitcoin uses proof of work, Bitcoin and Ethereum uses proof of work, and the scalability of a Bitcoin is highly scalable. Bitcoin and Ethereum are highly scalable. And we have some, when coming to scripting, we have some limited possibilities for Bitcoin, and Ethereum and Hyperledger will have the higher possibilities. So these are the generations of blockchain. It started from blockchain 1.0 to blockchain 3.0 we have. So coming to blockchain 1.0, the example which can make you clear is like our previous old age phones, like Nokia phones, which will give us access to only calls. When coming to blockchain 2.0, it is smart contracts. These are nothing but like our smartphones, which have the possibility of calls and access to different apps. And now the blockchain 3.0 we have, that is nothing but decentralized applications. This is an ecosystem of all the apps where you can have the access to all the apps, like your Paytm or your different banking apps or any food applications, or your riding like Uber, Ola and all. So we have these, the blockchain have been started its version from 1.0, and it has now we are following this 3.0, that is with the decentralized applications. So blockchain 1.0, as I told you, as I gave you an example, it is like our Nokia phones which we used at the starting. Only it is accessible to only the calls. We cannot do any sort of transactions in that. And the blockchain 3.0 we have now, that is by using decentralized applications, so that we can run by using the Ethereum. This will have a huge concept, as our is only introduction. I'm covering only the introduction part. So this blockchain 3.0 has applications that been beyond currency. Nothing, it is not limited to only one particular thing. It is being used in Bitcoins, even in finance and all other markets which we have, and in the area of government, health, science, literature, and culture and art. And we have, as I told you, that blockchain will be used in this security, smart contracts, digital currency, and record keeping. So these are all the use cases of that. We can use this blockchain in equity, in private markets, in e-commerce platforms, in global payments, in supply chain, and in intellectual property. This is blockchain beyond finance. That is, blockchain is not only used for the purpose of Bitcoin or cryptocurrency. It is being used in all these fields, like in the field of power, supply chain, agriculture, healthcare, and public sector. Like when coming to power, including like power generations, distribution of power, retail, and power to power transactions, like P2P transactions. Instead of depending on that centralized one, we can make it a decentralized. And in supply chain also, we are using this, like our food sector or agriculture or health sector. And in manufacturing industries also, we can use this, like whenever a product is being manufactured by the manufacturer, we will be giving it a digital passport, like we will be giving it an identity called as a digital passport. Each product will be given that. So whenever a blockchain entry that records its origin, its materials, and all its production details will be collected and stored in that. So when you want to buy that, you can scan and you can verify whether it is genuine or not. So that may be this manufacturing industry. You can use this in our automobiles and many types of luxury goods we will be purchasing. In all that, it will be useful by using this concept, like we will be assigning each and every product a digital passport. And these are all the blockchain use cases in this supply chain and spare parts. So BMW and Ford are using blockchain to track the resourced materials, like their batteries. And if there are any child labor involved in that also, they can track that in their mining platform. So this blockchain ensures that manufacturing is the thing will be transparent and trusted, even for the customers and as well as for the business people. So these are the use cases and supply chain of the spare parts. So you can track here and you can prevent any counterfeit parts. So fake spare parts, the main problem is the fake spare parts have been sold by the retailers, especially in this automobile and this aerospace industries. So that may be causing a risk to the lives of the people. So fake car parts or bike parts, they can cause accidents. So by using the blockchain, now each spare part, if you record it on a blockchain at the time of its manufacturing, then every movement starting from the factory to its distributor and to its dealer, workshop, customer, until it reaches to the customer, all this will be logged into a block. So whenever a mechanic installs a part, they can scan the QR code or any RFID chip to verify. We can verify by using that scanner to verify whether that part is genuine or not. So with this I conclude, like these are the users of blockchain, and I have covered only the introduction to explain you each and every part. We have lot in this, because blockchain is not just only used in the form of bitcoins. Previously we used that in Bitcoin. Bitcoin, only the transactions we used to make our currencies, like secured transactions. But apart from Bitcoins, this is really used in our real-time lives, even in our agriculture, even in our day-to-day lives, like our industries. And mainly first, this is used especially, we can use this in agriculture and even in our food supply management, because in food supply management also we are facing many sort of problems. Until that food reaches the customers, we are unable to detect whether the food is being good or spoiled. So by using this blockchain, what happens is it will track the data. It will track the data starting from the farm, from where our food items are being collected, who is the like in which area we have that, from which area we have collected that, all those can be collected. And even in voting systems also, if we use this blockchain technology, we can eliminate, like we can overcome the problem of fake votes, and we can overcome the problem like different people, like a single person casting many votes. We can overcome this problem. Even this is being followed in Estonia, a European country. It is already using a blockchain. It is already using a blockchain for digital voting in national elections. So this system will make the system transparent, secure, and it will reduce the cost of whatever. If we are using for elections, we can reduce the cost of elections, and this will make our process fast and fraud proof. So thank you, ma'am. So this is all from my side. If any queries.